So we've done a lot with confidence intervals and hypothesis testing for means, and now we're going to look at confidence intervals for proportions. So let's start with a little bit of notation here. We're going to let P be the population proportion, so the percentage of the population that has some kind of characteristic that we're looking at. And we have P hat for our sample proportion, the actual proportion or percentage of the actual sample that has the property that we want. And when we do these, we are going to once again be using the normal distribution, so we are going to need our central limit theorem to hold. We do need our sample size to be large enough. We can't do this with tiny sample sizes. We're going to need at least 30. Here's the basic formula for finding the confidence intervals for proportions. P hat is our sample proportion and N is our sample size. And just like with confidence intervals for the mean, the Z value comes from our confidence level and how confident it is that we want to be. We're essentially using a normal approximation, so we still do have the normal distribution. We're letting the center be P hat. And we're essentially figuring out how far up and down we have to go so that this percentage here has our confidence level. And these values would be given by Z times the square root of P hat 1 minus P hat over N. This one would be P hat plus, and this is P hat minus that thing. And that would give us our confidence intervals, just like we had confidence intervals for the mean. For us, we're going to actually use the GeoGebra graphing calculator. And the command for that is Z proportion estimate. We then insert the sample proportion, the sample size, and the confidence level. So let's look at some examples. Our first example, we have a sample of 487 people, and that showed that 48% of them drink coffee in the mornings. We want to find a 90% confidence interval for the true population, or for the true proportion. So with this confidence interval, we do have percentages and proportions here, so we're going to want to use the Z proportion estimate. From there, we need to enter the sample proportion, in this case 0.48. We need the sample size, 487, and we need the confidence level, which is 90%. We can now go over to our graphing calculator. So here's the GeoGebra graphing calculator. We hit the 3 dots, down to statistics, and we want to go down to the Z's to the Z proportion estimate. From there, we enter our sample proportion, which is 0.48. Our sample size was 487, and our confidence level is 0.9. So we have 0.443 and 0.517. So here's our confidence interval. We know the true proportion is somewhere between 44.3% and 51.7%, and we're 90% confident that that is correct. So there is a 10% chance that we're off, but we're 90% sure that the true proportion of people that drink coffee is between 44.3 and 51.7%. For the next example, we had a survey of 1,500 people that revealed that 450 of them have a college degree. We want to construct a 95% confidence interval for the true proportion of people with a college degree. So we're doing proportion. We can see that in the wording of this problem. So we know we need to use the Z proportion estimate. The next thing we need is the sample proportion. And in the last problem that was given to us, but in this problem it's not, so we're going to have to actually form it. We know that we had 450 people out of 1,500, so it would be 450 over 1,500. The next thing we need is the sample size, which is 1,500. And finally, we need our confidence level, which is 0.95. Now we can move over to the graphing calculator and see about figuring out what this confidence interval is. Here's the calculator. We'll hit the 3 dots and select the Z proportion estimate. Our sample proportion was 450 out of 1,500. Our sample size is 1,500, and we wanted a 95% confidence interval. So we have 0.277 and 0.323. So we have that there is a 95% chance that the true proportion of people with a college degree is between 27.7% and 32.3%.